In other videos, we've reviewed the regions for NMR, IR. Let's review coupled carbon NMR and then how it relates to DEPT. So in organic 1, when we first learned about carbon NMR, we talked about coupled carbon NMR. And so it's a little bit different than what we normally see as NMR. Here we actually see multiplicity. So when we saw a triplet on a carbon NMR, that implied that that carbon had 2 hydrogens. Now, we don't often see coupled NMR because of the ratio of hydrogens to carbon. Sometimes that signal gets a little bit muddy. So let's kind of review just a few more examples. If you had a quartet, that would be carbon with 3 hydrogens. So it's the carbon plus its neighbors to give you that signal. If you had a singlet, it's a carbon with no hydrogens. If you had a doublet, it's a carbon with 1 hydrogen. And so remember, those are the letters. Now, the coupled NMR, like I said, when we learned about it, is not terribly reliable. So we use DEPT to kind of give that same information a little bit more reliably. So once you run your DEPT and you phase your NMR and all of that, so in lecture you wouldn't have to do that kind of thing. Let's see what you show up on a DEPT 90. On a DEPT 90, the only thing that shows up is a CH. For CH2s, you see no peak. And I'm not implying any regions here, I'm just implying information. For CH3s, you see no peak. For carbons with no hydrogens, you see no peak. So how it translates to a coupled NMR would be on a coupled NMR, you should see a peak. That's a doublet. For DEPT 135, what you would see for a CH is it will go in a positive direction. What you'll see for CH2 is it will go into a negative direction. What you'll see for CH3 is it will go in a positive direction. And what you will see for a carbon with no hydrogens, you'll see no peak. So why run DEPT 90 and 135? It can help us figure out what are some of the signals that we have, especially if they're close and they're very similar to each other in terms of environment. Sometimes that's helpful. I'm going to say not sometimes, all the time, in real life, that is. The other thing that it's helpful for is by running them both. A DEPT 135 alone is only going to be able to give us whether for CHs, whether it's a CH or a CH3, we can't actually tell the difference, right? Because they're both positive. But what it can help us by running DEPT 90 is to differentiate between a CH and a CH3. So if you run both, and if it shows up on the DEPT, then you know whatever that peak was a CH. If it doesn't, then it's a CH3. So how does it translate to the coupled NMR? So that CH on the coupled NMR will show up at as a doublet on the coupled NMR. So not on the DEPT, but on the coupled NMR, the CH2 would be a triplet, the CH3 would be a quartet, the C with no hydrogen would just be a singlet. So if you had we're going to do a prediction of a NMR. I'm just making up a structure. So we have some alkyl carbons. So these two are alkyl. I'm going to label them A, B, C, and D. So I would expect that if I saw A, it's a CH3. So it should be the furthest. So if I were doing a coupled NMR, it has 3 hydrogens, so I would expect D to show up as a quartet. But on the DEPT 90, it's not there. On depth 135, it's positive. Okay. B is very electronegative, so I should see it even more downfield, but not, you know, not past 100. Since it has one hydrogen attached, so unlike proton NMR, we're looking at neighbors. For carbon NMR, you're looking at the neighbor on the carbon, so the hydrogen on the carbon. So there's only one there, so that should be a doublet. On the DEPT 90, it's positive. Oh, sorry. On the DEPT 90, this should have, yeah, should have no peak. What am I saying? Ignore that. The DEPT 135, I think I made a decent example so that I could show all of those things. On, so this is peak A, B. So C, I would expect that to have, because that has one hydrogen, that should also be a doublet. And it should be over 100. So it's a doublet, it's near the electronegative element, it has other carbons around it. It's a doublet on the DEPT 90. This would show up for us as no peak. On the DEPT 135, this should be positive. And for D has two hydrogens on it, so it should show up as a triplet. On the DEPT 90, no peak. On the DEPT 135, it should be negative, right? So it should point down.